everybody, and welcome to Unit 1, Lesson 9, which is Selecting Procedures for Determining Limits. We only have one learning target today. I can use graphical and algebraic features of functions to select an appropriate strategy for calculating the value of the limit. What I'd like to do in this video is just recap all of the strategies that we have for determining the value of a limit of a function. Now, this is more of sort of a thinking video where it's what is the thought process my brain needs to follow in order to find the limit for a function. So the first thing we should do is we should review kind of that it's possible to find limits using a graph or using algebra. Algebra is really where it gets kind of tricky, so that's what we're going to focus on in this video, is that we can use appropriate algebraic features of functions to select an appropriate strategy. So what's the first thing you should do whenever you're asked to evaluate a limit? Well, the first thing you should do whenever you're asked to evaluate a limit is try direct substitution. If the limit as x approaches c of f of x, and you plug in the c value and you get a real number, then you're done. Now, what if you plug in that value and you don't get a real number? So, what if you plug in and direct substitution doesn't work? There are really two things. Did you get an indeterminate form? So, did you get 0 over 0? If so, try factoring and resubstituting. Because that may allow you to now substitute your value successfully. If you did not get 0 over 0, is there a vertical asymptote? Which means you get some number divided by 0 when you try substituting. If you get a number divided by 0, if so, then you should substitute a number near your desired x value, and your answer should be either positive or negative infinity. Now, you're going to know whether you get positive or negative infinity by looking at your problem. If you have a number divided by a very small number, then your answer is always either positive or negative infinity, and you'd make that determination based on the signs of your numbers. But there is a third situation. It is possible that instead of those situations, are you finding the limit as x approaches positive or negative infinity? For example, does your limit say x is approaching positive or negative infinity? If so, you are looking for the end behavior of the function. So you should only look at the highest powers. Now, the tricky thing here is that we need to know about the relationship between polynomials and exponential functions. If you have a polynomial divided by an exponential function, then the exponential function is always bigger than the polynomial, so your limit will be 0. All right, I hope this kind of helps to summarize the different algebraic techniques that we have that we can use to find the value of a limit. And we will be doing some practice problems where these are kind of all mixed together so that you're forced to think through this thinking process. Thank you guys so much for watching, and I hope to see you soon.